Today we're going to be talking about section 1-2, which is on properties of real numbers. Now, real numbers is a set of numbers that we generally work with in mathematics. Real numbers include rational numbers, which are anything that can be written as a fraction, where a and b are integers, and the bottom of b is not 0. Irrational numbers, which is when your decimal never repeats or never ends. So kind of like pi is an irrational number. It goes on forever, never repeats. Integers are positive and negative whole numbers. Then there's whole numbers, 0, 1, 2, 3, and so on and so forth. And then natural numbers are like what you learn when you're a little kid. You start at 1, 2, 3, and so on and so forth. They're whole numbers. Okay? Now, the one thing we like to look at generally is this kind of picture right here. So the natural numbers is my smallest amount. Then whole numbers, I add 0 to it. Okay? Then I get integers, which are positive and negative whole numbers. Then I get rational numbers. Okay? And then after rational, I also have irrational. Okay, so you'll notice that irrational right here is all by itself. Okay, that's irrational numbers. They're not rational. It doesn't include natural numbers, whole numbers, all that stuff. It's all by itself. And then that whole thing makes up the real numbers. Okay? Makes up the whole thing. This first example we're going to look at, we're going to start naming the sets of numbers in which each one of these is included. Now there's some certain letters or symbols that represent each set of numbers. So I'm going to look at letter A, negative 23. Now I always start at the smallest amount and work my way up to bigger. Okay? So if I look at this one right here, negative 23, well, it's a negative number. If it's negative, it means that it's going to be an integer. Okay? We use the letter Z to represent integers. Okay? If it's an integer, that means that it's a rational number. Q represents rational numbers. And then finally a real number. Okay? So ZQR, integer, rational, real. Let's look at letter B, the square root of 50. Now the square root of 50 is not a perfect square. So if I was going to take the square root of this on my calculator, it would be some long decimal. So what that's going to end up being is an irrational number. Use I for irrational. And if it's irrational, then it's also real. Okay? So IR, irrational, real. Finally, the last one, negative 4/9. Okay, so negative, okay, but it's not a whole number, so it's not an integer. But we said anything that can be written as a fraction is a rational number. If it's rational, it's also real. Okay? You can try these guided practice problems on the bottom below. So, we have some properties of real numbers in both addition and multiplication that work no matter what. So we have some letters A, B, and C. Okay? The commutative property says that A plus B is the same as B plus A. And you can think of an example. 2 plus 5, 5 plus 2. They both equal 7. Same is true in multiplication. A times B is the same as B times A. 3 times 2, 2 times 3. They both equal 6. The associative property is where my parentheses are located. So if I was going to add A and B and then add C, it's the same as if I was going to take B and C first and then add A to it. Both of them give the same thing. It's also true in multiplication. You multiply the first two numbers first, then the third number, or second and third times the first. Now the identity property is interesting. Okay? What it says is that for any number A, if I add 0 to it, I get the same thing. It's also true if I take 0 plus any number because commutative property says it's the same. But identity is 0. Anything I add 0 to is still going to be the same thing. Now, for multiplication, it's going to be 1. So if I multiply any number by 1, it's still that same number. It does not change. Inverse property says that for every A, negative A, if you add them together, it's going to equal 0. And for multiplication, any A, if you multiply it by its reciprocal, 1 over A, you're always going to get 1. And notice A can't be 0 because 1 over 0 is not a rational number. Okay? Not a real number. It says closure right here, A plus B is a real number. So if you have a real number A and B, then together it's going to be A plus B is also real. Same with multiplication. If you're multiplying two real numbers together, Okay, your answer is going to be a real number. Finally, the last one, distributive property. Distributive property in addition says this: A times B plus A times C is the same right here. Okay? Same right here. If I was to have that A on the outside, same thing. B times A and C times A. And you'll see, okay, because we have commutative property of multiplication, BA is the same as AB. Okay? And CA is the same as AC. So let's look at this example and example number 2 real quick and see which property is used. Well, 5 times 4 times 13 is the same as 5 times 4 times 13. So which one of our properties says that I can change my grouping symbols and I still get the same thing? Well, that right there was the associative property, and you can abbreviate the way that I did. Okay, the associative property of multiplication. Okay, if you want to write the whole thing out, that's fine, but I'm going to write it like this. The associative property of multiplication says that if I change my grouping, it's still the same thing. Okay, down below, guided practice problem. You try that one right now. Example 3, multiplicative and additive inverses. Find the additive and multiplicative inverse for negative 5/8. So, negative 5/8 plus what number is going to equal 0? Okay, we want it to equal 0. Well, the answer there would be a positive 5/8. Okay, positive 5/8. So that's my additive inverse right here. Okay, additive inverse is right there. And now when we look at multiplicative inverse, we say negative 5/8 times what number equals 1. Okay, well, I want the top and bottom to be the same. So we said multiplying by the reciprocal, that would be 8/5. And then since this is negative, this one over here also has to be negative because we want a positive 1. Okay, so this right here is my multiplicative inverse. Okay, multiplicative inverse is right there. Here's some guided practice problems you can try as well. Example 4, distributive property. Okay, it says the price of computers in a computer package offered by Computer Depot are shown in the table. If 6% sales tax is added to the purchase price, how much sales tax is charged for the computer package? Okay, so you'll see the total prices right here. Now there's 2 different ways you can do the distributive property. You can either multiply all of them first and then add them together, or you can add them all first and then multiply them together. Okay? So what I'm going to do is it says to multiply them all right here. Okay? So we're just looking for the sales tax. We just have to multiply everything by 0.06. Okay? Remember 6% is the same as what decimal? 0.06. And this is actually how you find sales tax all the time. So I take all of those numbers and multiply them by 0.06. And I'll do that in just a moment. Now, in the sake of time, I just multiplied them all and just wrote them down for you. And if you wanted to, you could pause the video right now to write them all down too. So here we have 21.60, we have 13.20, 4.74, 8.97, and 5.94. So we can add all of those together. So we go to our calculator, 2160 plus 1320 plus 474 plus 897 plus 594, and I get a total of 54.45. So that's how much sales tax is going to be on this whole computer package. Okay? Now the second method in which we can try actually says we add them all together first, and then we multiply. So I'm going to pause the video and add them all together first, and then we'll multiply. So I added them all together. I get 907.44. So what I'm going to do then is, now that I've added them all together, now I can multiply them by 0.06. So I go to my calculator and I do 907.44 times 0.06, and I get 54.45. So it's the exact same amount So it doesn't matter the order if you multiply them all first and then add them, or if you add them all and then multiply them. But they're both going to give you the exact same answer. Here's a guided practice problem. You can try this one. Now, last example we're going to look at. Okay, we need to simplify this expression right here. So I see right away that I have 3 times everything in here. That's the distributive property. So I'm going to do that real quick. 3 times 2x is 6. Q. 3 times 2q is 6q. And 3 times r is going to be 3r. I'll also do the same over here. So a positive 5 times 4q is a positive 20q. And then a positive 5 times a negative 7r is going to be negative 35r. And what I can do now is combine my like terms. So 6q plus 20q is 26q. And 3r plus a negative 35r is a negative 32r. There's my answer right there. Here's a guided practice problem for you to try as well.